Okay, so here's section 3 now. We're kind of going to go back to approximate integration again. So we've actually already done this. We've done left, we've done right, and we've done midpoints. Those are all approximations. I'm just going to show you two others that are very popular and much more accurate. And why are we bothering with this? Well, you're going to see why. I mean, we'll talk about this later, but differentiation is very straightforward. Integration is not. So sometimes the shortcuts that we get to don't work. So you will need to use approximate integration. And then sometimes there's no formula for the function, right? If you don't have a formula, you can't use the definition. So this actually does play more of a role. The approximation was just to get you started with differentiation. You can differentiate anything, not so with integration. So the two that we're going to talk about are, the first one is the trapezoidal rule, and this is really just averaging left and right. So this is left, this is ln, right, and this is right, this is rn. So if we add these two up and divide them by 2, that's the trapezoidal rule. It's a much better approximation. So the delta x is common to both. I can factor it out as delta x over 2 because we're doing that. Now, notice that the left endpoints, they start with 0 and they go to n minus 1. And the right start with 1 and they go to n. So there's 1 n minus 1, right? So if we're looking down here at this, let me highlight this, the formula. This is what I'm talking about right now. So there's one fx0 that's contributed by the left endpoint. Now fx1 is in both, fx2 is in both, fx3 isn't. That's why all the 2's are there. And then fxn, the last one, that's only contributed by the right. So that's the reason for the 1, a bunch of 2's in the middle, and a 1. Again, t of n, t for trapezoidal. And so all it is plug and chug. I mean, it's just adding up a bunch of rectangles. So I'm not going to spend any time doing this here in the notes. You'll practice a little bit on the homework and the worksheet, and then that'll be it. Again, it's approximate, right? It's an estimation. So this is the formula for the trapezoidal rule. Okay. The other one that we're going to use, which is the most accurate, is I'm not going to get too into it. You can look it up if you want. Instead of trapezoids, right, averaging left and right, instead of using basically triangles on the top, this uses parabolas. It's called Simpson's rule, named after an individual named Simpson. And again, it's an approximation. I'm not going to get into where this comes from, but n needs to be even. Notice that this is delta x over 3, and then there's a pattern in the middle. So the n's, fx0 and fxn, those contribute just 1. And then it goes, the next two inside are 4, and the next two inside are 2, and the next two inside are 4, etc. So it goes 1, 4, 2, 4, 2. The penultimate is 4. I love that word. And then the last one is 1. That's why n has to be even. Okay? Again, I'm not going to get into the derivation of Simpson's rule. If you want to look it up, I'm sure there's plenty of stuff on YouTube about it. But all you need to do, again, it's just plug and chug. So I don't even know, did I give homework? Yeah, I did. So here I'm going from 1 to 2. I'm asking you to do M10, T10, and S10. Again, just plug them into the formulas, and they're going to be approximations. And it's very, very similar for the homework, right? So here I'm just doing Trap and Simpsons, and we're going to round to 6 decimal places. And so we're going to do T8 and S8 and T6 and S8 for these functions. Okay. Again, this is, you should do it a couple of times. I'm probably not going to put this on a test because it's a little tedious, but you should know how to do it.